Hello, everyone. Okay. This is the last session, right? After the session, you may go back to home or I may have some drink with my friend. Nice to meet you. My name is Terry, a customer engineer from the cloud team. It is really honor to introduce our Stackdriver logging use case, Samsung. Before I introduce our customer, I will briefly introduce logging itself and the Stackdriver. Okay, let's start. So what is logging? Logging is gathering event and the information to see the state of the system. Just a few years ago, we just used the logging for the troubleshooting and the debugging. And we collect the log into the single file and monitor it by using the tailing command, right? But the logging can be used for the multiple purposes. For example, for developer, log can be used for the debugging and code optimization. For the system engineer, it can be used for the health check and the system monitoring. For the security engineer, it can be used to protect the system to find the abnormal behavior. And nowadays, data engineering is being more important. So the data can be gathered through the log to find the insight In this reason, we need to collect more logs from the various layers. For example, we can collect the CPU and the memory status from the infrastructure and the OS level. And we can get a web access log from the web server or the database. Also, we can collect the log from the user of application. These logs can be used for the multiple purposes, like business analytics, auditing, billing, something like that. Because of that, we need more footy terminal. Okay? Until now, it may be okay. But the problem is, system is being moved to the distributed architecture, like a microservice, right? Because of that, it may have a lot of log files. So with a single monitor, we cannot monitor the whole of log. So what is the solution? The solution is we can use more multiple monitors, right? But actually, it is not a technical solution. So I will introduce a technical solution to monitor the distributed architecture. Here is the general architecture of the logging system. We can collect the log from the system and send it into the message queue, like a Kafka. And behind the message queue, we can consume the log. The collected log will stored into the log storage system for the archiving purpose, and the log will be indexed by using the indexer for the search purpose. So user can search and view the log. But the problem is, as I mentioned, the log can be used for the multiple purpose, like data analytics or the system notification. And nowadays, machine learning is more being important. So the log data can be consumed by the machine learning system to train the model, right? This system can be implemented by yourself, or you can implement this system by compositing multiple open source. But the problem is it takes long time to learn, build, and it can also bring operational overload. So what is the solution? Google has a Stackdriver. Stackdriver is an operation and the monitoring system. It combines the logging, monitoring, debugging, trace, etc. If you didn't have a chance to investigate the Stackdriver, I strongly recommend you to visit the demo booth. I saw that there are a lot of Stackdriver demo. It is really awesome tool. In addition, the Stackdriver can run over the multiple cloud infrastructure, including the Google Cloud and the Amazon Web Service. Today, I will just focus on the logging only. In the Stackdriver logging, it can support the log collection first. It can collect the log by using the SDK or some agent. The collected log will be stored, and it can be searched and viewed in the built-in Stackdriver logging console. And the collected log can be routed to the multiple destinations. Stackdriver can be work like a log router. For example, it is very similar to the Kafka in the open source. From the log file, we can extract the metric. For example, we can count the number of the error, or we can extract the overall response time of our service. With define this metric, we can also define the notification rule. For example, if we have some number of incidents, you can send some notification message to the system operator by using the email or the SMS or PagerDuty and Slack. And the last thing is log management for the multiple projects. Nowadays, as I mentioned, the system architecture is being changed to the distributed way, so the application can be deployed into the multiple cloud projects in case of Google, and the multiple account in case of Amazon. If we have to monitor the all of log in different projects and the different cloud consoles, it may be very, very painful. So the Stackdriver can collect the all of log into the single place, and you can monitor the all log in a single pane of glass. Okay, let's deep dive each of log, each of feature. The first thing is how we collect the log. The Stackdriver provides the SDK. The SDK can be easily integrated with a well-known logging framework. For example, in case of Java, the SL4J and the logback is usually used. This is the Java example. As you can see, there are no code change. You just simply change the Maven dependency to inject the Stackdriver logging library. It is really easy. But unfortunately, sometimes we need to collect a log from the built-in solution like a database or the web server. Or sometimes your logging framework cannot be supported by the Stackdriver. In that case, we can use the Stackdriver agent, which is based on the fluentd open source agent. So you can collect the log from the file by using this agent. After you collect the log, you can easily search and view the log by using the Stackdriver logging built-in console. It is really easy, and you can also support the query language like this one. After log has been collected, as I mentioned, for the multiple purpose users, it can be routed to the multiple destination. Like Google Cloud Storage, it is for the log archiving purpose, and the PubSub can be used for the log streaming. So behind the PubSub, you can put the real-time analytics system or some transformation system for the data formatting. Or you can export the log into the BigQuery for the data analytics. You can export the log to the multiple destination based on the filtering rule. So it means that you can selectively export the log to the multiple destination. In addition, basically, Stackdriver logging pricing is based on the stored log size. If you have to store a lot of log, it can bring a cost issue. So the Stackdriver also provides exclusion filter, which means that you can selectively store the log based on the filter rule. And you can save the cost. Nowadays, the logging has more meaningful. I mean that a few years ago, we just logging for the troubleshooting, so the text message was enough. But the developer tried to consume some data, like a user ID and the transaction ID, price, from the log. In the case, the structured logging format is more effective, like JSON format or the CSV format. Stackdriver supports the JSON formatting. This is the node.js example. If you write a log with the JSON format, it is automatically mapped to the JSON payload element in the Stackdriver log entry. And if you export this JSON log into the BigQuery, each element in the JSON payload will be mapped to the column in the BigQuery table. So it helps you to more searchable and readable. From the stored log, we can define the metric. We already have some predefined metric, which is called as a system metric. We can get a data like a byte count or the number of log entry. But if you want to collect a specific information from your log, you can define the custom log in two ways. The first way is the counter metric. It is just simple counter metric, but you can define some condition. For example, I want to collect the number of logs that web latency is over than the 1.0 second. And the other way is distribution metric. it records the statistical distribution like standard deviation, sum, average. It can be used for example, it can collect the average response time of your service. And then it is an example how you define the metric. It is really easy. And with this metric, you can visualize the metric by using the graph through the Stackdriver monitoring console. It is one of the example of the web response time, and this is a heat map graph. You can get some insight about your system status like this one. After we define the metric, we can make some alerting system. With the predefined rule, the Stackdriver will send some notification to the various destination from the email, SMS, and it can send a notification to your application through the PubSub queue. Last one is a centralized logging. As I mentioned, in microservice architecture, each service can be deployed to the different system and different project in Google and the different Amazon account. So the collecting the log into some centralized system is very, very important. So Stackdriver can collect all of log into the one GCP project and can provide the single pane of the glass for the log monitoring. Okay. Until now, we quickly look through the logging system with the Stackdriver, but the logging system can be extended for various purposes, like big data analytics. It is a way how we can extend the logging system. In real world, when we try to use the log data for the big data analytics, actual data is really dirty. I mean that it doesn't follow the format, and it doesn't follow the type sometimes, and sometimes the field is null. So we need the data validation and the transformation. In Stackdriver, we can export the logging into the PubSub behind the Stackdriver logging and commissioned by the data flow. Data flow is open source version of the Apache Beam, which is very similar to the Apache Spark streaming, and it can be used for the big data analytics. So you can put some validation and the transformation logic in the Google data flow. But unfortunately, data flow requires some coding by using the Java and the Python. It requires a little bit tiny learning curve. However, instead of your manual coding, Stackdriver provides a template feature. It means that you don't need to code. By number of clicking in the Google Cloud Console, you can make a data ingestion pipeline. In addition, if you need to add some transformation logic, you can simply implement it by using JavaScript, which is named UDF, User-Defined Function. So the user-defined function can be uploaded to the GCS without any packaging, like a jar file in the Java. So you just simply upload it and point it out from the data flow console. During the data flow run, it will pull the transformation logic and convert the data format. By using the Stackdriver logging, we can collect the log from the server side. But in big data analytics world, we wanted to collect all of user journey, from the advertisement, marketing, mobile, web. Fortunately, Google provides lots of solutions. For mobile, Firebase analytics can gather all of user event information and send it into the BigQuery. And for web, Google Analytics can collect all of user events from the website. In addition, BigQuery itself has a lot of data connector. We can collect the advertisement network data, Google Play, and YouTube data. As I know, in this week, Google announced that the BigQuery additional connector through the partner. So now we can collect over than 100 data sources across the SNS, advertisement, and the legacy system. So all of data can be stored in the BigQuery, and you can analyze the user behavior from end to end. It is really cool, isn't it? No? Thank you. Okay, the other problem in the microservice architecture is correlation of the log record. The problem is, let's say that the user A sends a request to the user service, and it will write a log into local file system, and it will send the request to the other service, like a service item service. User B also calls same thing. But the problem is, I want to track the user A's request only. So how can we correlate the user service and the item service log? The way is we can put some correlation ID, which is trace ID. So when user calls the user service, it will automatically generate the trace ID and store it into the log together. And if user service send the request to the item service, this trace ID will be propagated together and write into the log file. So by using this trace ID, you can correlate the log entry between the different services. You can implement it by yourself, but fortunately, there are open source named Zipkin. If you integrate the Zipkin open source into your logging system, it will automatically create the trace ID and propagate the ID to the other system. And the trace ID also will automatically return to your log file together. Actually, the Zipkin is not a logging system. It is originally designed to support the distributed system trace. It means that it can trace the latency in distributed system by interval. For example, I call the service, user service, and item service, but I want to know where is the bottleneck. How long time does it take for each service? After you Zipkin integration, Stackdriver also supports the Zipkin by using Stackdriver trace. Stackdriver trace will collect this latency information and visualize by using graph like this one. This is really good. But the problem is, to use a Zipkin, you need to inject your Zipkin source code to your application. But I want to collect the other system latency, which cannot be injected by the Zipkin. For example, database, web server, but I want to check the trace. In that case, we can resolve this problem in the infrastructure layer. Instead of fixing the code, we can put some proxy in front of the service, which is Envoy proxy. It is very similar to the HA proxy. But in the microservice world, we need to deploy a lot of proxy in front of each of service. Instead of that, Istio is managed Envoy service. It can automatically index the Envoy in front of your service. So regardless of the application program language, you can collect all of trace log. And this trace log can be integrated with the Stackdriver service monitoring. As you can see, that in the microservice architecture, topology and the service dependency is really, really complicated. But it shows the topology like this one, and it also provides important information like response time, error rate, CPU utilization, something like that. Okay, final thing is personal information. Personal information is very, very sensitive, right? If you store the personal information to the storage which is originally designed for the personal information handling, it may not have a problem. But sometimes, unexpectedly, the PII or user information can be stored in your logging system. It is critical. To prevent that, we can use the DLP API, Data Loss Prevention, which is based on the Google machine learning technology. It can automatically detect the user information, like a social security number or some other information, and it can anonymize or make it as a hash table, hash value. So it can prevent the personal information to be stored in the logging system. Okay. From last year, by using the Stackdriver logging, Samsung started to move to the innovation to SRE and the DevOps practice. So today, I will introduce head of Samsung Mobile Operation System, Jin Lim, to stage. Jin, is your turn. Thank you.
All right, it's great to be here. It's honor to be actually present my presentation in Google Next. Coming to this large of tech conference for me is really a treat for me. And I remember my first big conference was about 9 years ago, and I was infrastructure engineer, service engineer with this big software company. And at the time, it was about the cloud conference, and it was really eye-opening for me because as an infrastructure engineers, whenever an engineering team asks me to deploy, provision new server in the traditional data center, it takes about 3 months. I think like it's industry standard. Whenever you try to deploy a new server in a traditional data center, it takes about 3 months. But then, in this conference, they tell me I can provisioning number of servers in 10 minutes, less than 10 minutes, right? And it was like, this is where I need to be, right? With my career, I want to be in a cloud and I'm trying to do more of work, makes my life easier and helping our engineering team as well. That sort of feeling I had with the Google Next this year as well. When I hear about Anthos, it was like new world for me as well because I've been trying to move over some of our legacy system into a containerize it and be more efficient, more flexible. And it was really hard to get a lot of time from our engineering team asking code changes, right? But in this Anthos, we're able to do that without code changes, and it's free, right? So it's really great to have those kind of feature coming to the industry as well. But let me try it. Okay, so have you guys heard company names Samsung Electronics, right? Okay, good. All right. I'm pretty sure you guys know about Samsung Electronics. We create or build pretty awesome consumer electronics, including handset devices, right? Very innovative, and we have a list of a business inside of Samsung Electronics. But then Samsung, back in Korea, Samsung is not only about consumer electronic manufacture. We are in business of construction, insurance, and theme park, hotel, and many more of a business we are in Korea. So they said it's easier to list out the business that Samsung is not in compared to we are in. This huge technology company has a tremendous value in their name, and for the most of the college graduate, it is dream job to come into a Samsung and work for the company because one of the reasons is good pay, of course, and it provides job security. The reason is that we have such a big portfolio of business sector that if there's a downturn in one business, we can ship those people. We don't have to lay people off. What that means is we ship those, some of those people moving into another business sector. So, with the Samsung, with the big company, you have a pretty good level of job security as well. And so for some of the folks, it'll be great opportunity to work in a global environment. You get to talk to a lot of global smart people and try to learn your way in a career, trying to understand from the global environment. So that's another advantage those college kids wants to have as well. But then I'm pretty sure it was only reason that Samsung is also starting to be known as a service company. So I have a list of this application service that we are running, trying to add more value to our smartphone devices. For example, Samsung Pay is, in my opinion, most innovative service that we ever created in a Samsung Electronic, providing a digitalized credit card or a bank card into your phone, and you can virtually pay using this phone. You can pay anywhere that you want to pay, including this point of sale device only accept the MST, which is magnetic only. You can still use Samsung Pay devices, Samsung Pay services to pay with it. It's a huge success in Korea and some of the other countries as well. We have a Samsung account. We have Samsung Pass, which is a biometric authentication mechanism where, as long as you have a thumb And first, when you are trying to access network resource with your login information and password, after that information saved in the phone, you don't have to memorize that anymore, right? So that information is securely saved into your devices. All you need is the thumbprint to access any of your network resources. And we are also in a B2B business, and we provide AD-like, activity tree-like solution for Android devices, trying to work with our partner in the different business sector. I'm going to show you a little bit more about the Samsung AI system called Bixby.
Say hi to the new Bixby, Samsung's intelligent assistant.
Hi, Bixby. What's on my schedule this afternoon?
You have one event scheduled today at 1 o'clock p.m., meeting with Pattern Maker.
Change this event time to 2 p.m.
All set. I saved the event.
Hi, Bixby. Find Italian restaurants nearby.
Here are some Italian restaurants nearby.
Give me a table for 3 today at Luciano's at 1 p.m.
You're all set for lunch.
Hi, Bixby. Give me an Uber to work.
The fare for this ride will be $21.72. Ready to request ride?
Perfect.
Hi, Bixby. It's runtime.
Okay, turning on Bluetooth. Starting a run in Samsung Health, playing Run playlist.
All right, that's about the Bixby. Today, about 57 million registered users are utilizing Bixby services. And with the latest version of Bixby service, we are supporting Korean, English, and Chinese. And only this year, we added 5 more languages that most of European uses it today. And this year, next year, we're going to keep on expanding, supporting different languages on the global. And with 2.0 changes that we made with the Bixby, the huge change is we are trying to open up our AI system to our partners. We provide the same tool, machine learning tool that we are using in internal, and we're providing out to our partner to utilize that as well. And not only partner, as long as you are a developer, and as long as you know how to use our tool, you should be able to integrate it with the Bixby. It's sort of like Play Store that you can upload your app into a Play Store. You can do the similar thing with the Bixby development portal. So do find out more about from the Bixby development portal. If you wanna reach 57 million or users for your business, and including it's not only the handset device, it will be TV and refrigerator, any consumer electronic device can connect to a network. We will integrate with the Bixby in the future. In the next, my colleague Jooyoung will be explaining about the what are the challenges we've been having managing Bixby, big size of log with the 50+ size of microservices we are running today, and then how Stackdriver help us to addressing some of those problems. Jooyoung?
Hello, everyone. My name is Jooyoung, and I'm the DevOps member in the Bixby project. It's really honor to present my the experience here. I hope that our small the experience can give you the opportunity to understand how we overcome that situation about the logging, and it will be a good technical reference for you. Yeah, let's get into the background. Actually, we have the new Bixby services now, and it means that previously we have another Bixby services. Usually, when we call about the logging system is usually for the debugging and the monitoring, and also the analysis purpose too. But when the small size of the project or the services can consider that, maybe just to use the ELK for the logging system, or some kind of this open source solutions to overcome that situation. However, some services that is for customer service, or just the large scale services always try to build their own logging system. That is for the reliability and scalability too. And currently, the new Bixby, all log data is almost 1.5 terabyte per day, and we have to think about that how we can satisfy that the real-time monitoring with using that our internal logging system, and also we have to guarantee that the reliability and scalability too for the customer services. So when we think about the previous logging system in Bixby services, the major key point was that logging for debugging, and the other one is the cost saving point. Actually, the previous internal logging system was developed by ourselves, and that means that is not as the known solutions in the market. It was designed in our side and developed in our development team, and that is deployed to the cloud infrastructure. And mostly all requirement was as driven by our internal users. So it is more easy to satisfy all the requirement when we develop ourselves for the logging system. However, when we want to add new features like the tracing or E2E testing, then we have to change every infrastructure and the design concept of the logging system. But that system was not designed at that time, and simply they logged all log messages into a logging system, and simple monitoring was only supported by the Grafana. So we have some of the challenges. How we can provide that the tracing mechanisms to the developers to give some the help how they can debug their the issues when some issue is detected in their own applications. And indeed, when we are adding the new logging system into our cloud infrastructure, that goes the more complex, the complexity of the system goes much higher than we expected, and it is not easy to adding new features to the new logging system, as well as the cost is also goes up high, and the cost was one of the big challenges for us to reduce the infra costing fee. So that is the majorly two request for the DevOps team side, and we have to change, or we have to find out any solutions available in the market. So we got some suggestion from the other team, and that was not from the Google actually. We searched that the Stackdriver in the Google at the website, and we found that we have to check that what is our key feature for providing that the new logging system. So firstly, we have to think about the real-time monitoring. Stackdriver support that real-time monitoring as based on the log-based metrics. So as well as the logging system as using the Stackdriver, it also can support the real-time monitoring, but it is also is provided easy ways to integrate with the other monitoring solutions. We in the Bixby 1.0, we have another the internal monitoring solution, and that is also have to be continuously to use for our operations. So we have to check that whether the Stackdriver can support that the third-party monitoring solution integration, and we can guarantee that that is possible. And second, the important thing was the on the logging system is the experience of debugging. So now, a previous logging system, when the developers want to search any logs, only the application the driven logs can be searched at the time. The one problem was all the developers cannot make the standard log format at the time. And a huge number of developers in Samsung was involved in this Bixby development, and they made their own style to remain the log messages. It doesn't show any related log messages for debugging purpose. So it means that developers want to check that whether this new detected issue belongs to their problem or to another module's problem. We have to provide any tracing mechanisms to developers for providing the easy ways to search the log messages for debugging. So when we check that the Stackdriver, it also can support that the tracing mechanisms as using the automated trace. However, it cannot be applied to our internal the requirement. Actually, if we want to add that the auto-created the tracing ID, we have to persuade all the developers to apply that requirement to their source code. It is not easy. I think some of you are working in the big company. The big company have several the organizations, and even though that organization only belongs to the development team have their own strategy and the policies. It is not easy to adding the new code for only the tracing purpose into their code, because they just worry that any side effect and the performance degradation due to the adding the new mechanisms to their own code. So we have to make sure that tracing is also need to be adding the new the logging system, and we made a new standard log format to apply that the Stackdriver. And secondly, previous logging system also provide that the analytics the system. It means that some of the log messages should be gathered, and that is sent to the another analytics platform. And that platform is gathering all data and providing the analysis data. We have to make sure that the Stackdriver have to support that, and we had to check that whether that is available. So after checking that all requirement, we can go with the Stackdriver without building the internal logging system. Internal logging system usually require too much effort to develop, and also we cannot satisfy that all the project milestone to go forward. So now we could do that. We have to do that about the log format standardization to satisfy the tracing purpose. The other one is that usually when we build a new logging system, always we have to think about the user management. So when we use the Stackdriver, all the authentications or user management is undercovered by the IAM policy. And the Stackdriver log viewer is basically supported, so that every users who get some the permissions to access the log viewer pages, then they can immediately search the log messages from the console, by accessing the console. And mostly important thing is that some of the infra-related system metrics is automatically created by the Stackdriver agent, and it is sending to the Stackdriver services. But we also need another the custom metrics too, which is generated from the application side. So one of the big things about the Stackdriver is that they can support the log-based metrics, and even if we can communicate with the other application developers, and we can define that any metrics in that the log messages, then it can gather by the filtered the log-based metric, and that it is one of the materials for the operation and monitoring. So now we have the simple diagram. So all logs, which is stored in the each modules, is gathering by the servers, and from the Stackdriver logging agent do that all the data is gathering and transfer that data to the Stackdriver service. And then we can integrate with the Datadog, one of the our major the monitoring solution, and that is gathering all the log-based metrics, and it can show that the one unified format of the dashboard. It is currently we are not going to the SRE practice yet, so we have the transitional the operation the practices now, so that every tier 1 and tier 2, and even though the tier 3 is using that to get some any issue detection by our own dashboard. Also, we also use the Stackdriver monitoring tool too, because that dashboard also providing that any custom the dashboard creation, and that is also related with can be integrated with the other solution like the open source Grafana. And we have used the Slack channel to notify every warning or the communication for the convenience, and if we can define that some alert in the Stackdriver and the Datadog, then it can automatically send that the Slack channel, and then it can goes to the stakeholders to investigate any issue or for notify that any operation process. Basically, the debugging is also can be available when we access to the log viewer, and for analytics purpose, we are gathering that all the log messages and filter them into the cloud storage, Google Cloud Storage Services, and it is going to the analytics system by pops up. So finally, we can say that after applying that the Stackdriver for logging system, we can have a number of the effectiveness after using the Stackdriver. Firstly, we can talk about the cost saving. We can say that at least 3 times lower than a cost saving was possible when we use the Stackdriver. So it means that we don't need to think about any infra changes or the maintaining the system. Only that we can give all effort to service reliability and scalability. And it means that secondly, we can minimize all the workload. So we don't need to think about any maintenance about the logging system. We can fully give the energy to service reliability. 3, when we use the Stackdriver, we also realize that unified this logging system can be applied to another project if that requirement is really similar with the Bixby project, so that our operation team has much number of the services, as Jin mentioned, so that if it is possible, we can add that the Stackdriver to the other services as using the unified platform of the logging system. Finally, we also, even though we integrated with the analytics system internally in Samsung, but better scalability and the purpose of the data analysis is also possible when we're using the BigQuery. So this is the last the pages. So I will back to the Jin. Thank you.
All right. I know this is the last session, and I know you are eager to go back to your home and so on. But I will make it quick as possible. But this is my talk that I wanted to do, practicing SRE, trying to make that happen in our environment as well. So let's see. So some of the challenges as in Samsung Electronics we had. I joined the company in 2013. I came from the large software company based in Redmond, Washington. Spent about 10, 12 years there. And I got hired by Samsung and moved my family to Korea. And back then, there's some other guys like me who came from a global successful software company. And then Samsung wanted to make an environment where the software development management is kind of normal to our company because the company is not came from their software-based core business. Their core business is manufacture. Right? So they try to create the environment, try to create the culture of software development. But then, as company put more investment on a software development, we create more service as go on. Every time we add more service, obviously there will be more people to operate those services as well. So as service being more added to the production environment, we need more people to operate and support those services. The problem is, we feel that we're not gonna able to justify ourselves of growing rate of the operation team any longer. So we need to think about new way of operation, still able to support a number of services coming into a production. As I being with the Samsung, I kind of lucky enough to witness all the changes being done in the software management inside of Samsung as well. As you can see, box product, right? So we release flagship devices every 6 months, right? We have S series, we have Note series. It takes about 6 months. Waterfall methodology of development lifecycle kind of makes sense. And box product, manufacture system, and we have all the important decision is being made by executives, and since we have enough time of lifecycle of these products, and obviously, back then we utilize a lot of traditional data centers to host our servers, and all the system is sort of like a monolithic architecture system. But then over the year, we know we can do this type of management anymore with the service development. So we change ourselves to agile coming from the waterfall, where we break down all the tasks, we create a backlog, and we try to fulfill give them the right engineer to actually responsible for those backlog. And we run every sprint and trying to ship out at the end the shippable product to a production. And all the decision is now being made by a PO, or every key feature in production, whether it needs to be going live or not, being decided by our product owner. And obviously, right now, majority of our servers are being hosted in the cloud, unless there are compliance that the server has to be in a traditional data center. And why going with this pattern of the break down each feature in the production, it makes sense to architect ourselves as a microservices instead of the monolithic. Still, old way of the development lifecycle, as I mentioned, we have 6 months of time on waterfall, and we could have all the time, every time we have new service coming in, we can, as an operation, we can find ourselves to ask engineer team, create an operation guide, KB article, and do the right training, what's coming into a production environment. And it all makes sense. But then with the project managed by Agile and Sprint, we don't have that luxury anymore. We don't have time to ask them, or engineering team does not have a time to provide all those information. So we also have a conflict between business and the engineer and operation, where our priority is providing stable service to our customer, where engineering team trying to push new value to our production environment. So we continuously having this conflict. While we're trying to solve this operation conflict and organizational challenge, we came close to chance to work with the Google SRE engineers, and trying to learn more about SRE practice how Google does their SRE practice in their end. And we ran through a lot of meetings and seminar with the Google engineers, but then we realized that Samsung is not Google. So what I meant is that we didn't came from software development company. We came from the very process-driven manufacturer culture in our back of our mind. So next thing that we did was, okay, so we understand what SRE can give us, what kind of benefit, but then we need to answer a how question. How can we implement this practice to our environment? So we start learning from other industry leader in practicing SRE. We learn from the Netflix, LinkedIn, Uber, and many others. And they all have something in common too, right? So they break down to each kind of separate the what's put it into production and separate the who should be responsible for addressing those issues. They have a notion of you build it, you run it. So if there's a developer who's trying to push it into production, and that person's supposed to know how to troubleshoot those issues, not operation engineers. So we really like those notion of the movement there as well. So we came up with our own version of SRE. We call it ourselves as a global service reliable engineer, and we break down to a different area of implementation. So before, pretty much every service that we are running today does have SLA. We do have a key index of availability. But then that's not enough for SRE practice. We want to make sure we kind of break down to each function within the service and making sure each function does, user impacting function does have a SLO as SLI. And also, we want to make sure the error budget is being communicated with the engineering team. So if you exhaust all your SLO, we will focus on making the reliable system instead of pushing new idea into a production. These are one of the example of a SLO document we have. As I mentioned, big service such as a Bixby have a different functionality, capability within the service. One of capability is ASR, which translate the utterance to text. So we create this template where we break it down to an application level as ownership of that SLO is primary ownership of SLO is that. We have underneath primary ownership of operation, which is us, managing infrastructure level of SLO. And one of the key points is infrastructure SLO is much tighter, higher than application SLO. Obviously, application SLO could not be met if the underlying framework is not there yet, right? So that's why we're trying to kind of differentiate between operation primary responsibility and engineering primary responsibility. With the help with the Stackdriver and Datadog, we were able to create the dashboard just for that SLA. So based on this SLA, if there's a SLO threatening event that is happening, we can integrate with the Datadog and Slack and some other alerting mechanism. We can give the alert to right engineers. And also, that comes into incident management as well. And before, we take traditional multi-tier escalation path, right? So we have a tier 1, tier 2, tier 3, which is essentially developers. If issue happen, tier 1 gets that and escalate to tier 2 if they don't have enough information to how to troubleshoot. And tier 2 in operation side is supposed to know most how feature is running in a production in the production environment. But if in the name of the agile and the service, as I mentioned, there's always lack of information what's running in a production in an application level. So we ended up calling developer pretty much every time. So if you think about SLO of 395 for availability, you have only 22 minutes of allowed downtime. So in the middle of the night, one of the incidents happening like this, it's easy to lose about 30 minutes. So for that month, if you have a single instance, you are violating SLO. So we needed to take the different approach in SRE, right? So we trying to pinpoint the actual error and do a better job in logging. We may not have to go through the tier 1 and tier 2. If system generate the right information and push those alerts to a right engineer, it could be a developer because event is trying to violate the SLO for application. It could go to infrastructure engineers if it's violating some SLO that we pre-built for network, right? So for example, so we can pinpoint the alert, and we can finish up doing we bypass the multi-tier escalation there. I guess I need to finish up really quick. Deploy management. We, same idea. We operation team used to own deployment of production environment. We call ourselves as a production engineer, right? So we have ownership of making stable and quality is there for business looking and customers looking. But then as we separating out with the SLO for developer and operation engineer, now we are making the infrastructure as a code, configuration as a code. Operation have ownership of pushing new changes if it's a configuration and infrastructure. Vice versa, development team have ownership of pushing new code into a production. And that way, we don't have to stop development to deploy new code into production, asking for a bunch of KB articles to how to troubleshooting, because this alerting, when they push a new idea and if there's a problem, the alerting will go straight to a developer, not to an operation who has nothing, knows nothing about those changes in the code. Cultural change is last thing, but it's not least thing. This is the hardest thing to do, right? So we kind of communicate this to our leadership, and they all get the idea. And first comment was the cultural innovation. You need to talk to make sure all people are in consensus, right? So we're starting to do a lot of brown bag seminar with the different engineering team, pushing this idea and make sure they're onboarded. And we ask for what it needs to be happen, and what help we're going to be needing from them as well. And some of the things that we did was we create a task force, right? So we create a task force or dedicated team to create the tool set, right? If we don't do application deployment, we provide the pipeline, CI/CD pipeline, that gradual change is embedded into a pipeline. Risk management is embedded in the pipeline. That it's no-brainer for a development team that if they're trying to push a new idea, but if it's starting to having problem, it's easier for them to roll back as well. So we're trying to create a team providing this type of a tool to engineering team as well. So that same goes with the logging and monitoring and QA automation. We don't have the QA automation, security automation yet. We have this multi-plan organizational change and trying to fit into this model of SRE. And while we're trying to provide across the same tool set for our SRE, we also have a service SRE who are actually working on that project, trying to plug in those platform solutions into actual services as well. I can't really say all the benefit we are having right now because we are still early stage on the adopting SRE. But then, we are kind of expecting to have a better visibility of our service with the measuring everything that what's happening in a production and reducing mean time to recover, obviously, right? So I'm trying to meet the SLO and reduce the release time with the CI/CD pipeline automation and optimize operation resources as well. So I think this is my last session. Thank you for joining us, and you may go to your family now.